This video, we're going to solve some application problems. You'll recognize some of these problems that we've already done from Chapter 5 and Chapter 6, but we're going to do them again. The surveyor is measuring the distance across a small lake. He sets up his transit on one side of the lake, 120 feet from a piling. Here's his transit. Here's the piling. Point across from a point that's directly across from a pier. So this is the piling. This is the pier. And this is the surveyor with his transit. That's a tool that he uses to measure. And from his transit, he found the angle between the piling and the pier to be 70 degrees. What is the distance between the piling and the pier to the nearest foot? So we want to know that. So tangent of 70 degrees is equal to x over 120. 120 tan of 70 degrees is equal to x. 120 tan 70 degrees is going to be to the nearest whole foot. X is about 330 feet. Now, a radio transmission tower is 130 feet tall. How long should the guy wire be if it is attached 8 feet from the top? So this is 8 feet, and then there's 122 feet down here. There's the guy wire. Make an angle of 34 degrees with the ground. We want to know how long this should be. Give your answer to the nearest tenth of a foot. So we're going to use opposite and hypotenuse. Sine of 34 degrees equals 122 over x. So x equals 122 divided by sine of 34. And they said they want this to the nearest tenth, so x is about 218.2 feet. A straight trail with a uniform inclination of 18 degrees leads from a lodge at an elevation of 500 feet. So here's lodge at 500 feet above sea level to a mountain lake at an elevation of 8,500 feet. So this is a rise of 8,000 feet here because we still have the same 500 feet from when we started. What is the length of the trail to the nearest foot? So we want this distance x. We're going to say opposite over hypotenuse is sine of 18 degrees. It's going to be 8,000 over x. X is equal to 8,000 divided by sine of 18. And we get that the trail is once to the nearest foot. So it's about 25,889 feet long. building that's 150 feet tall casts a shadow that is 30 feet long. The person looks down from the top of the building. What is the measure of the angle between the end of the shadow and the vertical side of the buildings? They want this angle there. To the nearest degree, assume that the person's eyes are level with the top of the building. So tan theta is equal to 30 over 150, which is equal to 1 over 5. Theta is equal to arctan of 1/5. And theta is about 11 degrees. John is about 6 feet tall. Just going to put John's eyes right there, his eye level. Is trying to estimate the height of a tall oak tree. So here's the oak tree. Right? He first measures the angle of elevation from which he is looking at 35 degrees. So that means that he's looking up here. This is position 1 for John. He's looking up 35 degrees there. And he walks 30 feet closer. So when he walks 30 feet closer to position 2, he's going to look up to the same point. One pen. There we go. Do my best to draw that line. There we go. That's pretty good. And that it's increased by 12 degrees. Oops. Hang on. Position 2, he's still here. There we go. And so it's increased by 12 degrees, making this 47 degrees. He's still 6 feet tall when he's there. Estimate the height of the tree rounded to the nearest whole number. All right. So we know that this is x, and this is x plus 30 on this side. This big side is x plus 30. And we know that this side here we're going to call y. So we're going to say that tangent of 35 degrees is equal to y over x plus 30. And we're going to say that tangent of 47 degrees is equal to y over x. So x tangent of 47 degrees is equal to y, and x plus 30 tan of 35 degrees is equal to y. And since they're both equal to y, I can set them equal to each other. X tan 47 is equal to x plus 30 tan of 35. X tan 47 equals x tan 35 plus 30 tan 35. I'm going to bring my x's to the left here. Tan 47 minus x tan 35 equals 30 tan 35. Factor out the x, tan 47 minus tan 35 equals 30 tan 35. So x equals 30 tan 35 over tan 47 minus tan 35. So let's figure out what that is. That only gets me to what x is. That doesn't help me figure out what y is yet. But 30 tan 35 divided by quantity tan 47 minus tan 35. Close that up, close the denominator up. I'm going to save this number. I'm going to store it as x because I need that. And now I'm going to say that x, this number, times tan of 47. This number is about 56.44, but I'm going to use all the digits that are available to me from the calculator. So I'm going to write out all of them. I'm just going to say is equal to, even though it's not exactly equal to, it's close enough to this, 389511. So that means that y is equal to x tan 47, which is equal to 60.52866699. But I'm not done because I still need to add 6 feet for the height of John, because the tree is 6 feet taller than where his eyes are at. So my height of my tree should be 66.53 meters approximately. I kept all those digits in the middle so that I could get the most exact answer at the end, and I rounded one time to the nearest whole number, excuse me. So 67. 67 feet. That's my fault. 67 feet. I was going to say that's too large for a tree. Okay, 67 feet sounds better. That's still a really big tree. All right. A photographer points a camera at a window in a nearby building, forming an angle of 42 degrees with the camera's platform. So here's the window. Here's the camera here. The camera is 52 meters from the base of the building, or from the building. So here's the wall here. How high above the platform is the window? So I want that side. It really doesn't tell me how high the platform is above the ground, and it doesn't matter. And the angle here is 42 degrees that the camera is looking up to the window. So we want tangent of 42 degrees is y over 52. So 52 tan 42 degrees is y. 52 tan 42 degrees. So y is about 46.82 meters. They told me to go to the nearest hundredth of a meter. A tree casts a shadow 26 meters long. When the angle of elevation of the sun is 24 degrees, find the height of the tree to the nearest meter. So tan 24 degrees equals x over 26. 26 tan 24 is x. 26 tan 24. And we're rounding to the nearest meter. So x is about 12 meters. 25-foot ladder reaches the top of the house, forms an angle of 41.5 degrees with the wall of the house. How tall is the house? So we're going to say cosine of 41.5 degrees is equal to x over 25. So 25 cosine of 41.5 degrees is equal to x. 25 cosine of 41.5. And we're going to round this to the nearest tenth of a foot. So x is about 18.7 feet. Number 13 tells us that there's two hikers on opposite sides of a canyon, and they each stand precisely 525 meters above the canyon. So they're on the same level footing, 525 feet above. They each cite a landmark of the canyon on the floor on a line directly between them. So here's the line between them. They're the same distance away here, and they're both looking at this landmark here. Okay. And the angles of depression, let me draw this a little better. So this one's up in the air here. This one's up in the air here. And this one is 525, and this one's also 525. And this one's looking down 37 degrees, looking down a little bit more. So this angle here is 37 degrees. This one is looking down only 21 degrees. So this one's looking down 21 degrees, and they're looking at the same point that's down here on a line that's between them. How far apart are the hikers here from each other? So we're gonna figure out this distance of this base and this distance of this base. So this angle here is 21 degrees, and this angle here is 37 degrees because those are alternating interior angles cut by a transversal, so they're congruent. So I want to find B1 and B2, I'll call them there. So the tangent of 37 degrees is equal to 525 over B1. So B1 is 525 over tan 37. Tan 21 is equal to 525 over B2. So B2 is equal to 525 over tan 21. So my entire base, which is B1 plus B2, is going to be 525 over tan 37 plus 525 over tan 21. Let's see what that is. 525 divided by tan 37 plus 525 divided by tan 21 is going to give me that B is approximately 2064 meters. It says to round to the nearest whole meter. From the edge of a 1,000-foot cliff, the angles of depression looking down at two different spots here. The angles of depression to two cars in the valley below are 21 degrees here and then 28 degrees here. So there's a 7-degree difference here. And I want to know, probably want to know what the difference is in how far apart the cars are. Yep, how far apart are the cars? So I want to know this distance here. But to do that, I'm going to have to say that this angle here is going to be 21 degrees, and this angle here is going to be 28 degrees. This is 90 degrees. And I'm going to have to say the big base here for the big triangle is from here. Let's call this A, B, and C. So you can figure out what I'm talking about. Side AC, the measure of AC, is going to be the adjacent side, and 1,000 feet is going to be the opposite side. So tangent of 21 degrees is equal to 1,000 over the measure of AC. And so AC is equal to 1,000 divided by tan 21. Tangent of 28 degrees is equal to 1,000 divided by the measure of AB. And so AB equals 1,000 divided by tan 28. And I want BC, which is going to be equal to AC minus AB. So that's going to be, come over here. BC is going to be 1,000 over tan 21 minus 1,000 over tan 28. Stick that into my calculator. 1,000 over tan 21 minus 1000 over tan 28, and we get BC is about 724.4, and this is in feet. They wanted us to go to the nearest tenth of a foot. That's why I rounded it that way. All right, that's it. So those are all of our application problems for section 7.1. Come back next time and we'll talk about 7.2.